So on the homework labeled Wednesday's homework, all these problems are factoring. Factoring, the idea of factoring is just moving backwards from multiplying. So this homework we multiplied. We took two binomials and we multiplied them out and it became a trinomial, something with three terms. So now we went from here to here. Now we're factoring, we're going backwards. We're going backwards. So we're taking this trinomial and trying to see if it turns into two binomials. We're seeing what can be multiplied together to get this product, right? So there's lots of them here. I'm going to focus on this problem right here, and then you can do the rest. So the first thing you need to do with all of them, the first step is you need to look for what's called the GCF, factoring out the greatest common factor. So you need to look through and see if there's anything that each term has in common that you could pull out. So for this one, I see that each of them right off the bat has y for a factor. So we know y can be factored out. And then I'm looking at the numbers. They don't all have an x in common, so x can't be factored out. But looking at the numbers, they're all even, which means at least a 2 can be factored out. And if I think about any higher number, 2 times 34 is 17, so 17 doesn't break down any further into factors, so 2 must be the highest thing they have in common. So I can factor out a 2y. So 2y is the highest thing that'll go into all of these. So now I need to write what's going to be left. So if I take a factor of 2 out of 24, that leaves behind a factor of 12. And if I take a factor of y away from this x squared y, that leaves behind the factor of x squared. And now I'm still adding. If I take a factor of 2 out from 34, I leave behind a factor of 17. If I take a factor of y out here, I leave behind a factor of x. I'm still adding here. If I take a factor of 2 out from 12, I leave behind a factor of 6. And if I take a factor of y away from here, that leaves behind no variables. So here is my greatest common factor factored out. And if you want to check your work, you can try to imagine the distributive property. 2y times 12x squared is 24x squared y. 2y times 17x, 34xy. 2y times 6, 12y. So you have a natural way that you can check yourself. But the thing is that we're not entirely done. We have now this trinomial that might be further factored. And if you remember here again, when we multiplied, we were taking these two and turning them into this. Now we're taking this trinomial. We can use the same tool. We can use this area model. But now we're kind of going backwards. We're trying to say, where do these three terms, how could I use this box to get what's on the outside? I need to move from the inside to the outside instead of outside in. So with this box right here, notice that this 2n squared, that goes here. And notice that this -6, that goes here. So I know that with my box, I can, if I'm trying to go backwards, I can make a box. And my 12x squared, this term, the highest degree term, goes right here. The least degree term, right, goes here. This is called standard form, right? So the first term is standard form and the last go here. But if you look back here again, you notice that these two, whatever they added up to was what this term came from. So we know over here that what goes in these two boxes have to add up to 17x. So they need to add up. So you can say sum needs to be 17x. Okay? But we need another clue because there's a lot of things that can add up to 17x. And we're not sure. I mean, it could be -1 and 18x. It could be 3x and 14x. There's just so many different options for things that sum to 17x. So the other clue we have is it turns out that if you multiply along this line, this line should multiply the same. So the product here should equal the product here. So that's the other clue. The sum should be 17x, but the product should be these two multiplied together. 12 times 6 is 72, and then there's the x squared. Now, we were practicing this with diamonds, and if you liked that, you can either write it like this or you can use the diamonds. Sum is 17x, the product is 72x squared. Either way, this is just a shorthand for saying that. We need to find the two terms. This is enough to let us know. We need to find the two terms that add to 17x but multiply to 72x squared, right? So right away, I can tell that I'm going to need something with an x on either part, because something with an x on either part will add, those would be like terms to add up to this, but they would multiply to the x squared. So I know this has to have x. Now we need to figure out the numbers. What two numbers multiply to 72 but add to 17? Well, I'm going to start by listing what multiplies to 72, because that's a limited number. We just talked about there's an infinite number of pairs that will add to 17, but there's only a limited number of integers that will multiply to 72. So I'm going to take 72 and I'm going to break it up into pairs that multiply together, and I'm going to do that systematically. I'm going to say, well, how many times, if I start with 1 times 72 equals 72. Do those add to 17? No, so that's not going to work. Now I'm going to do 2. 2 times 36. So 2 times 36 multiplies to 72, but do they add to 17? No, so that didn't work. Now I'll try 3. 3 times 24 multiply to 72. Do they add to 17? Nope, so that didn't work. 4 times 18. They multiply to 72, but they don't add to 17. 5, well, 5 doesn't go into 72, so that doesn't work. 6 times 12 multiplies to 72, doesn't add to 17. 7, well, 7 doesn't go into 72 at all, so that doesn't work. 8 times 9 goes into 72, and it adds to 17. So I now found that it's 8x and 9x that go there, right? So 8x and 9x go in these boxes, right? So great, I figured out what goes in the box. Now I just need to figure out what's on the outside so that I can get my two terms. So figuring out what's on the outside, you can puzzle it out, but really a quick way to figure out what needs to go right here, that's kind of the hardest part, is we're going to go back to greatest common factor. What do these two terms have in common that could be factored out? Well, they both have a factor of x, so I can pull a factor of x up. And they both have a factor of 4. 4 can be pulled out of 8 and 4 can be pulled out of 12, so pull up 4x. Now I really just need to kind of figure out what goes on the outside here. Like 4x times 3x will give me 12x squared. 4x times 8x. 4x, what times 4x will give me 8x? Well, 4 times 2 will, right? And then here, what needs to go here so that the inside works out? Well, 3 times 3x gives me 9x. 3 times 2 gives me 6. So I did that right. So the final step, we need to write the whole thing out in factored form. So we still have the 2y as a factor. But now we took this trinomial and we turned it into two binomials. 4x plus 3 and 3x plus 2, right? So this is the final factored form where we've got this greatest common factor and then we've got these two binomials that all of this would multiply back out to that. So these are equivalent. If you graphed them, they would produce the same graph. If you could graph something with y's and x's. And so we know that we factored that properly. If we did, we could use our graphing calculators to help, or we could multiply it back out. So it's a long process, but if you go through step by step by step in practice. So I want to see you trying with all of them. It doesn't need to be perfect, but you need to practice this and see if you can get it right.